Hi ladies, sorry I can't be with you today, but we are going to do our last lecture regarding net ionic equations for chapter 11. So I'm going to first tell you what a net ionic equation is, but then like I said from the past, you'd be able to predict your own products, and specifically we're going to predict our own precipitate. So this is very similar to what we did in your lab this week. So just go ahead and take some notes on the notes guide that I gave you, and when I return on Wednesday, we can go over some review problems. So, as you know, a lot of our world is composed of water. Just take a look at this globe, right? Uh, it's said that over 70% of the earth is water. And so one thing that you notice in our balance equations is not only do we label solid liquids and gases, we also have to label aqueous items because those are very have their own characteristics. So today we're going to work with a lot of aqueous compounds. So here is an example just to tie in a couple things that we did. So yes, these are pictures from yesterday, but we are going to relate our net ionic equations to basketball. Obviously, I like the Lakers, so they're right there. And tonight was our last basketball game, so here we have some seniors and some underclassmen who so kindly allowed me to use their pictures today. So as you guys know, in order to play a basketball game, you have to have two teams, right? And each team has to have 5 players. And the most important thing, you need, oops, sorry, wrong one. You need to have the basketball. These things right on the court are very critical to this game. However, those are not the only things that are necessary, because what's a game without any fans? So here are some of our fans from yesterday, as you can see, so patiently waiting to watch the game. And so one thing that we're going to do is we're going to see which compounds are our main players, right? You can't have the game without the players, right? But which of our ions are going to be our spectators, just like the people we have on the outsides. They aren't necessarily required for the game to happen, but it wouldn't really be a game without the spectators. So just remember this image of our spectators right here, along with our basketball necessities in the middle as well. Okay? So these are the kinds of equations that we've worked with before. It's just a normal balance equation. This equation is already balanced. And if you notice, this is a double replacement reaction. So one of your quiz today was actually learning to label your types of reaction. A lot of times we do this when we have double replacement. We can also do this with single replacement, but it's always easier to catch when it's a double replacement equation. So you have already learned how to do these 4 pieces, but remember how I said when we do the face, there's a couple more steps? We're going to learn that second half of the face today. So you will always be given a balance equation. Sometimes you will already have the products, but you already also know how to form those products. So this is where our starting point is. Okay. You are receiving this chart today. It says solubility of an inorganic compounds in water. You have a copy from your proctor. You're welcome to use this on quizzes and tests as well. And we are going to have to make reference to this. So make sure you have this. A couple things that I would like you to label is this section right here. I'd like you to make sure you label that as solid. Anytime it says there's a soluble compound. Oh, just kidding. Right here, where it says form soluble compounds, when we say that we are soluble, that means we are still considered aqueous. Okay? So in here, I would like you to label this column as AQ for aqueous. We also have another column here that says largely insoluble. So when we say something is insoluble, that means we can't break it down in water. So usually that tends to form in a solid. So we're going to label this as our S, also known as our precipitate, right? So make sure you take this into account. What this means is if I say, let's say I am using this one of these anions over here. Let's say nitrate, okay? If I'm using nitrate and I try to combine it with any of these cations, they're usually going to be aqueous. So since most cations belong in this box, that means we would label our product as aqueous. However, let's say I'm using, that's another color, acetate right here. If I was using most ions, I would be here and also be aqueous. But if I'm ever trying to combine acetate with silver and Ag+, I notice that this is in my S column. So whenever I crisscross silver and acetate, I would have to label it as a solid. So I'll go back and go over these with you once we get to that point. Okay? So one thing we want to take a look at is some vocabulary. In this whole category of net ionic equations, you're always going to start with a complete ionic equation. So this shows every single ion that is dissolved in water, also known as aqueous. So just a reminder, these are everything that are aqueous. So what happens is, our previous problem right here, I'm going to break down everything that's aqueous. That's exactly what we've done in the past. So when I break that down, I get an Ag plus an NO3 minus plus a Na plus a Cl minus. And from the face, so if I were to draw my mini face right here and right here, we would get this AgCl. And because in this problem I'm telling you these are aqueous, I actually can't combine them because if they're aqueous, they're going to break down in water. So these are just samples right now, and I'll show you how to do one of these together. What happens is we have spectators, right? So our spectators are required for the reaction to happen. However, at the end, is it the spectators that win or lose, or is it the team that wins or loses? Technically, it's a team that wins or loses, and it's the fans that support them. So what we do is we end up crossing out our spectator ions, and those are ions that remain ions on the reactant side as well as on the product side. So if you notice, just like in math, when I have an X on one side and an X on the other side, I'm allowed to cross them out. I'm allowed to cross out this, let me use a different color, this NO3 and this NO3 because they're exactly the same on both sides, as well as this Na and this Na because they're exactly the same on both sides. However, I am not allowed to cancel this Ag+, nor am I allowed to cancel the Cl- because on the product side, I actually had a solid solid form, sorry. So we label our spectator ions as Na+ and NO3- since we were allowed to cross them out on the other side. And so, just like in math, anytime you cross things out, you need to rewrite your equation so that it's a little cleaner. We're going to do the same exact thing. What we're going to do here is we are going to rewrite this and this, since we did not cross those out, as well as this to create a new equation, which is now called our net ionic equation. So, I hope that got a laugh. Our definition of net ionic equation is here. However, all I really want you to know is your net ionic equation is this right here. I took my ion and showed what kind of precipitate was formed. And just like with anything, we must balance. I have 1 Ag, 1 Cl, 1 Ag, 1 Cl. So this equation is actually already balanced for you. So that's a general idea, but I want to walk you through the different steps. So if you take a look at the next section, I give you 9 different steps. The good thing is you've already done a few of these. Whenever we did double replacement reactions, we always broke down all our aqueous compounds. We combined the outside ions. We combined the inside ions. We wrote the products on the other side, and we balanced. Today, we're going to focus on steps 5, 6, 7, 8, and 9. Number 5, we're going to need to use the resource sheet that I've given you to find out how do I label these as solid, liquid, gas, or aqueous. Then again, I repeat, I break down my aqueous compounds. A new step is to cross out our spectator ions. And finally, I write the net ionic equation, and as always, I balance. Okay, so if we take a look at this one, the first step always says break down your aqueous. So I'm going to break down these aqueous ones, and I get Ca2 plus and an OH minus. And on this side, I get an H plus and an NO3 minus. And just like before, step 2 and 3 are cross the insides and the outsides. If I cross the outsides, I notice my charges are different, so I do have to do a crisscross. And I do parentheses NO3 with a little 2. And in the middle, I notice my charges cancel. And if I were to write this, I would get HOH. Well, what do you know about HOH? Well, HOH can actually be written as H2O plus I get the Ca parentheses NO3 close parentheses 2, right? So I have to balance this, and if I balance this, I notice I need 2 NO3s. So if I stick a 2 right here, I believe that actually fixes everything. Is that right? H2O, Ca, oh no, I have to fix this by putting a 2 right here, okay? Now our next thing says, well, I need to make sure that I figure out are these solid or aqueous or liquid or gas. So if I take a look at this, we already know at room temperature, what is water? Well, water is a liquid, so I know I can label this as a liquid. Calcium nitrate, however, I have no idea what that is. So what we're going to do is we're going to go back to our little resource sheet. And I'm going to make this just a little bit bigger so you guys can see. We're going to look for nitrate. And if you notice, nitrate is right in that very first, it's on the very first column right here. And if I take a look at nitrate, it says no common ion is insoluble, which means if no common ion is insoluble, that means this needs to be aqueous. So I go back into my equation, and I'm going to be able to label this right here as aqueous. Sorry, I ran out of space, right? So according to this, the next step says, well, break down your aqueous. So if I take a look, I'm not allowed to break this one down. Sorry, there's an arrow right here, right? I'll just use another color. I'm not allowed to break that down, so I'm going to just leave it down here as an H2O liquid. Plus, I'm able to break this one down because it's aqueous to Ca2 plus plus NO3 minus. Our next step says cross out all of your spectator ions. So which ones are my fans in this problem? Good, I have a Ca2 plus here and a Ca2 plus here. Laker colors, right? And then I also have an NO3 minus here and an NO3 minus here. So according to this, my spectators, I'm going to just say spec right here, are Ca2 plus, the 2, and NO3 minus, right? However, the players of this game have to be what's left over. So if I bring all of this down, I know that I have yet to use this right here as well as this. So if I write my net ionic equation, and I'm going to label that here, net ionic, what we get is H plus plus OH minus, and I just do that because we always like our cations first, to yield H2O liquid. Then final step, I check if I balance, and yes, I see I have 2 H's, 1 O, 2 H's, 1 O, and we are done. So this is one example of how we do this. What you are going to do is you have to make sure that you can really learn to use the resource sheet. So here's what you guys are going to do in class today, and I'm going to change this up just a little bit just to make sure I give you guys the right kind of practice. I'm going to change this to CD over here. I'd like you to still do these right here, but now that I've done CD in today's class, I'd like you to do these ones for homework. That way we get an idea, and on Wednesday we'll go through these together. So please make sure you try to do all the problems and turn them in, or turn the exit steps in by the end of the class. Thank you and have a great, blessed weekend, ladies. I'll see you on Monday during advisement, and take care. Goodbye.